Right, hello and welcome to another Dauntless development video. This is, I believe, the 11th C# tutorial, and today we are going to be looking at inheritance. So previously we've looked at classes at one point, so that was tutorial 9 I believe, and classes, as we know, can have functions and data, so like variables, stored within them. Now, you might want to have specific different versions of a type of class. So, back at the example where I talked about a car, and you've got different types of cars, so you could have say a Ford or a Toyota or whatever. You could also just have different types of vehicles. So you could have a vehicle class with functions that vehicles would have, like move, and maybe variables they have, like number of wheels and top speed, etc. And then you could make other classes that then use that information that they all share, but then can have their own specific information. Like, for example, a bike will not have have anything for, like, using a clutch, for example, like a car might. So there's different things. So if you think of it like this, you've got this vehicle parent class at the top, and then beneath you have a class that inherits from it. So this can take all the information from the vehicle class, the bike one, but it can also have its own special information. So these two share all the information and all the functions that are in this class here. It's actually no, you can't see my cursor. Can you? No, you can't. Okay. Sorry. So yeah, the bike class here and the car class share all the information that's inside this vehicle class at the top. But the bike class and the car class can still have their own separate information. So that's an inherited class. This is what is called a child class or a subclass. This would be the parent or superclass. Now, or base class, that's another way of calling it. You can also inherit further, so you could have bike, and then you could have that split into other ones like mountain bike. I'll just put mountain for short. And you can have then a road bike. And then etc, etc. And then you could even go further down, if you wanted to specify even further, down to like a specific class for like a brand, and then you could do different things. You can keep going as far as you want. But the idea is this at the top is going to be your most abstract one, so the one which can cover as much stuff as possible. And then you get more and more specific as you inherit further and further down. So if you kind of understand that concept, we'll move on to actually putting it in code. So you can see here we've got just a normal program as always. And what we'll do is we'll start off by making a class. So we'll go to add class, just like before. I'm going to start off with the vehicle class. Vehicle. So here we have the vehicle class. Now what we can do is we've previously discussed public and private. So public. So if you got, so we'll make a variable here just called top speed. So by default this would be private. So you have private. Now private means it can only be accessed from inside this specific class. Public, if you change it to public, means it could be accessed from any other class. But what we've got for inheritance is a special one called protected. Now protected works the same as private, except it can also be accessed by any class that inherits from this class. Now, so top speed, we want everything beneath it to inherit. Generally, when you're working with classes that inherit, you're going to have almost everything as a protected variable or protected function, because the reason you want to inherit from it is because you want to be able to use that stuff in the child class. It's like, well, it'll be protected or public, because if you want it accessible, like if it was going to be public originally, then you'd probably have it public. So we've got this protected top speed, protected float. Now what we can do is we can then make another class. So I'm going to make a new class here. I'm going to call it let's say bike. oops, not bike, bike. I believe it deleted that period there. There we go. So you've got bike, and I'll make car as well before I do any changes. Class car. Right, there we go. So we now have two classes called bike and car. Now, what we can do to make them inherit is we add a colon here next to the name car, and we then put vehicle. So you can see it there on the list. So now this car class inherits from vehicle. And we'll do the same to bike. So, vehicle. So, what we can do now is we can now access this here. However, there is one caveat to that. You can only access the protected, anything that's protected in the parent from inside functions in these child or subclasses. So, for example, this protected float top speed, we might need to, although to be fair, you probably wouldn't have this, well, you might have this under protected, but it's probably going to be just a variable in the vehicle. But if you wanted to do something special with this variable, what you can do is you can then say, you can make a function. So I'm just going to make a void. I'll just call it func. And I'll have it take a float. I'll just call it s. And then I'll say, in fact, I'll give it the name set speed. And what we can do is we can then access our top speed variable here. So we can say top speed equals s. So we can then change that protected variable from inside the child class as long as it's inside a function. That is one caveat, because if we try to access top speed outside of here, it doesn't come up. So it has to be inside a function if you're accessing a protected variable. Now, as I said, the benefit of this is you can have like a lot of information stored in your main like parent class, stuff that you don't need to have in all the others, and then you can only have what is very specific to that, meaning that if you make a change to say you're working on a program, and say you've got a game and you've got lots of different vehicles. We'll stick with this kind of topic of vehicles. And for some reason you discover that you need to change the way all the vehicles move. Maybe every single vehicle has a problem in the way they move. Rather than having to go through every single different type, you can just change it in the vehicle class, and then that will change it across every class, as long as it is inherited from it. And you also get the benefit of being able to put specific behavior in without having to put all the code in, say, one class. If you just had them all only use the vehicle class, and then you would have to use lots of like if statements. So say like if it's a bike, then do this. If it's a car, then do this. With this kind of setup, you can just have all of them be vehicles by using these specific ones. So you can access all this information whilst also having specific behavior here, like kind of like change gear, or pedal, or stuff like that. Use your indicators on the car, but then you don't need to have that behavior accessible in the bike because, well, you don't have, although I think you can get indicators on a bike, but that's besides the point. Generally, you wouldn't expect indicators on a bicycle. But yeah, that's kind of just a brief look at inheritance. What you can do, which is one thing worth covering, is if we have a function here, so we'll have a function called protected move forward. Oops, and we'll want to make it void move forward. Now, this is just going to do something. We don't actually need to like execute any of this code for the purposes of this. But yes, say we have this protected void move forward, and what we can do, as we've discussed, is say in car, we could say in the set speed. I know it's a bit odd, but you could call the function called move forward. Yes, so you could call the function called move forward here. So move forward. And we could do that. But obviously there's no real purpose to that, but I'm just showing that you can access it still. But what we can do, which is a bit more interesting, a bit more useful, is we can say protected virtual. And what this means is this function can now be overridden by a child class. And what I mean by that is we can have behavior in here. So we could say console.writeLine, and I'll say this, oops, I need to put a string in. This is the vehicle class. Oops. So this is the vehicle class. And then inside the car, what I can do is I can have a public override. In fact, I think it's going to be protected override. And you see, it comes up with a little suggestion of using move forward. So we can now call this override here, and this will, when the vehicle that it's being called on is a car, in this case, it will choose this class, this function, sorry. But as it recommends you do to begin with, it automatically puts in base.moveForward. Now what that does is, as I said, the parent class can also be referred to as the base class. So what this does is it calls the move forward function in the base class. So what we can do here is we can have console.writeLine, and then I can say this is the car class. Now I've just realized for kind of what I want to do, I'm going to have to make this public, and probably the other one as well, because it's going to get upset if I have them be different. So public, there we go. So now it's all cleared up, all the errors. So now what we can do is we can have a vehicle. So I'm going to make a vehicle called V, and I'll just say equals new vehicle. Oops. And then I'll just say v dot move forward. So now when we run this, what you can see is this is the vehicle class. So that's what we expected. We made a vehicle. But now what we can do is if we, instead of having this line and this line, we'll leave that there, but if we make a car, C equals new car, actually put that there, then we can say C dot move forward. Now, as you would expect, it will run the behavior from the car class. So you see, so it starts off by saying this is the vehicle class, and then it says this is the car class. Now the reason for that, as I said, is we say base.moveForward. So this first of all calls the version of the function in the base class, and then it calls the version of the function inside the car class. Or, well, then it will carry on with the code here. So we don't need to put this base call, so we can get rid of that, and we can say start now, and it will just say this is the car class. So obviously this is very useful because, like, with kind of a bicycle, when you move forward, you might not need to do any extra behavior. But when you have a car and you move forward, you might want to consume fuel or something like that. There's obviously stretching this kind of analogy, but if there's different behavior you want to happen when you do the same thing, then you can specify like this. But yeah, that's kind of all we need to talk about for inheritance. There's a lot more you can do with it. It's very, very powerful. It's not only very powerful, but it's very convenient for organization. It means that, as I said, if you say find a problem in your vehicle movement, then you could potentially fix it all in the parent class and it will automatically fix everything else. Because if you think, you could potentially inherit like tens of classes from one place. And if you fix it all at one point, then it saves you a lot of time and effort having to troll through code, finding the same things in each bit. But yeah, so that's all for today. And I'll thank you for watching, and I'll see you next time.